All right, so this is the Earth Science Regents from January 2023. Make sure your name's on this one. Once again, bring it for the next 3 days. Let's open up to question 1. By the way, you do need to have out an Earth Science reference table with you. You will write all over this document. I want you to put notes, just like I'm going to be putting notes on it. You do the same. Question 1. The apparent change in direction of swing of a Foucault pendulum at one specific location provides evidence that the Earth does what? So the Foucault pendulum is that big steel ball that swings back and forth. And if you remember, I showed you a video where it knocked down pins over a 24-hour period. That's how long it takes for them to go around. So, which one of these things does it provide evidence for? Earth traveling around the sun, spinning on its axis, tilted, or spherical? So the answer is spinning on its axis. It takes 24 hours for this Foucault pendulum to do one complete rotation. So in order for it to do that, 24 hours, well, that's a day. Question 2. The presence of cosmic background radiation is evidence that helps support the what? Yeah, the Big Bang Theory. So the cosmic background radiation is kind of like an echo from the Big Bang. So when the universe first formed, all light, energy, matter moved away in all different directions. And as that energy moved away, it redshifted. So it went from bright white to red, but it kept shifting. It's so far in the past that it shifted into the infrared. And infrared, as we know, is heat. We could see this as a signature in the background of space. Cosmic background radiation, that infrared radiation, is evidence of the Big Bang. 3. In New York State, the highest altitude of Polaris will be observed at what? What is the relationship with Polaris and its altitude? The altitude of Polaris equals what? The latitude of the observer. So, if the altitude, the angle up to Polaris, equals the latitude, and we're looking for the highest altitude, what are we also looking for? We're looking for the highest latitude. So which one of these guys is at the highest point? Earth Science Reference Table, page. What page? Where do we find cities? Excellent, page 3. So we're looking for the highest one up. We've got Messina and Plattsburgh all the way at the top. Messina. 4. Earth's rate of revolution. Revolution means to go around. Or we could say orbit. All right, so how many degrees are in a circle? 360 degrees in a circle. And how many days does it take for the Earth to go around the sun? 365. So 360 divided by 365 is approximately 1 degree per day. 5. As water vapor changes from a gas to a liquid, what do we call that conversion from a gas to a liquid? Yeah, we call that condensation. So as it goes from a gas to a liquid, it's condensing. How much energy is either gained or released? ESRT page. Excellent, page 1. So if we go to the right side of page 1, we've got our properties of water chart. We're looking for condensation. The energy will apparently be released and it's 2,260 joules per gram. So it's released joules per gram. Questions on that one? That's a simple one. That's like gimme. Question 6. At the time of an equinox, the subtropical jet stream in the Earth's troposphere generally are located closest to what? All right, let's go to reference table page. Where are we going to find weather stuff? 13, 14, but in this one it is 14. So here we're looking for the subtropical jet stream. Our subtropical jet streams are located here and here. Now, if you remember, a jet stream is a torrent of wind. It's like a big, like a river of wind traveling through the atmosphere. And as it travels around the Earth, it can force weather patterns to do different things. Now, here you can see the subtropical ones are located at 30 degrees north and 30 degrees south. But we also have polar ones. Polar ones are at 60 north and 60 south. But for this question, subtropical, 30 north, 30 south. Question 7. This is a bit of a tricky one. Dry bulb temperature is 16 and the dew point is 7 degrees. What are the wet bulb temperature and the relative humidity? All right, so we're going to be looking on reference table page what? Excellent, page 12. So for page 12, we're looking at the dry bulb temperature is 16. I'm just going to write down on a blank sheet of paper here, dry equals 16 degrees C. It says the dew point equals 7 degrees C. And we're looking for the wet. And we're looking for the RH. Okay, so how do we do this? Well, if the dry is 16 and the dew point is 7, let's go to the dew point chart. We're going to find dry of 16, and we're going to move across until we bump the 7. So we already know that the dew point is 7. So now if we move up, we could find that the difference is a 5-degree difference. Well, if I know that it's a 5-degree Celsius difference, and I know that the wet bulb is always colder than the dry, 16 minus 5 would give me 11 degrees Celsius. And now I just got to calculate my relative humidity. So let's go to the RH, 11 and 5. Relative humidity, 11 and 5. (16 minus 5 is 11). 11 and 5. So there's 12, so 11 and 5 would be there. So we're somewhere between 54 and 57. Did I do my math right on that one? Dry 16. 16 and 5? Oh, yes, that's why. I'm sorry. 16 and 5, because you're always going to be using the dry on the side. So 16 and 5, so let's try that again. 16 and 5, that would be 54. All right, so our wet bulb temperature should be 11, and our relative humidity should be 54. Our answer is 4. Question 8. Which ocean current warms the climate along a continent's east coast? ESRT, what page? Where do we have our water stuff, or oceans? Excellent, page 4. So if we jump into page 4, first thing you want to notice, guys, who's talking? Please stop. If you notice on page 4, we've got here warm currents are black, cool currents are white. We're looking for warm current. So, California current, is that warm? No, it's cool. Falkland current? Cool. So it can't be either question 1 or question 2. That leaves me with Brazil or Guinea. So these are both warm. And you can see that by going to Brazil. Brazil current is black, and the Guinea current is also black. So those are warm. But the question's asking on the east coast. Now, if you remember, your cardinal directions are as follows: north, south, west, and east. Never eat soggy waffles, or you can remember, as you're facing north, it should always spell we. So in this case, which one is on the eastern coast? We've got Brazil on the east, and we've got Guinea on the west. We're looking for the eastern coast. The answer is Brazil. Question 9. Which process transfers heat energy through molecular collisions? Well, radiation, that travels through space. This could be things like radio, or it could be light, or it could be microwave radiation. So that has nothing to do with molecules colliding. 2, convection. Convection currents, which we should be pretty familiar with by now, we could find them in the Earth's atmosphere. So let's say that this is the troposphere. And let's say we have a warm day where the air is warming up and it's moving up. It expands, it cools, and it comes back down. This is what we call a convection cell. And these convection cells only happen in liquid, I should say, or gas. So it's either liquid or gas. So in this case, when we're talking about molecular collisions, no. Infiltration is not an energy transfer process, but conduction is. Conduction, like for example, if you have a wire, the electrons in a wire are literally all bumping into each other and traveling down the wire. Molecule to molecule contact. 10. 2 major greenhouse gases that can be found in the Earth's atmosphere are what? CO2 and methane, CH3. So in this case, those are your 2, but we actually have a third one. Do you remember what the last one was? Water vapor. And this ties in with water's amazing ability to have a very high specific heat. Water can hold on to a lot of energy. 11. Which event causes a temporary slowing or reversal of the ocean currents in the equatorial regions of the Pacific Ocean, which may disrupt normal weather patterns in North America? I don't think we went over this. This was one of those things I cut out for lack of time. So let's take a quick look at reference table page 4. So on page 4, go for it. Page 4, we have the south equatorial current. Now, these equatorial currents are moving, in this case, warm to the west and more warm going to the east. Now, depending on the time of year and other factors, sometimes this current reverses itself. We're not 100% sure why. Maybe caused by global warming. But when it does, that hot water that's supposed to visit Australia turns around and it goes to South America. Now, when that water is warm here, that means there's cool water here. Now, the warmer the water is, the more precipitation we get, because you get more evaporation, more precipitation. When we have this event where it reverses like that, we call that an El Nino event. The reason why, El Nino in Spanish means the baby or the boy, and that refers to baby Jesus, Christianity, because it happens around Christmas. Yeah, and that's why they gave it that name. Now, if that were to happen, Australia is not getting that warm water. Australia is not getting rain. So Australia becomes dry. And then the South America gets more precipitation, and it causes other climatic effects that affect North America. So your answer to this one is El Nino. Really, the only thing you need to know about this is ocean, let's say ocean currents. Question 12. The map below shows the time zones of the continental United States. The dashed lines represent meridians of longitude. The locations of Cleveland, Ohio, Portland, Oregon are shown. What time is it in Portland, Oregon when it is 9 in Cleveland, Ohio? So here's Cleveland, Ohio, and they told us it's 9 p.m. And if we know that each time zone is 15 degrees apart, which those are 15 degrees, that's 15, that's 15, then that means that that's 9, this would be 8, this would be 7, and this would be 6. Our answer would be 2. Each time zone in the United States is 15 degrees. Not exactly, but yes, it's going to be 1 hour for each jump. Now, if you remember, the Earth's rotation is 15 degrees per hour, and that's where we get that from. So if this is 9, that would be 8, 7, 6. As you go to the west, you're going to go back in time, and as you move to the right, you're going to move forward. So for example, London is 5 hours ahead of us, and if I know that London is 5 hours ahead, and I know that each hour is 15 degrees, well, 15 times 5 is 75. I'm sorry, 15 times 5 is 75. So I know that it's 75 degrees to the east of us. Question 13. Diagram below represents the constellations that are visible above the southern horizon at midnight for the same New York State location on 2 different dates of the year. Why are different constellations seen on these different nights? I can't tell you how many times we've drawn this. Okay, I'm tilting my Earth to the right. It doesn't matter. It can be tilted to the right or left. Question? Go for it. So it doesn't matter if you tilt it to the right or to the left. But here, it's just a matter of perspective. I'm tilting it to the right. Now, let's try to fill in the dates for these. So I can see that the northern hemisphere is pointed away from the sun. So can you give me a possible date? Yeah, so this would probably be 12/21. Why? Well, because we're going to be mostly in the dark. Now check this out. If I were to draw a line that would highlight the nighttime side, if you're up here and this is spinning, you're going to be mostly in the dark with only a little time in the day lit. And then if you're down here in the southern hemisphere in Australia, most of the time is light and a little bit of time is dark. So this would be our summer. On the opposite side, we've got 6/21. Oh, excuse me. I wrote them on the wrong sides. This would be winter, and this would be summer. We know that everything goes counterclockwise as seen from above in our solar system. So if it's going counterclockwise, if this is 6/21, this would be 9/21. Excellent. We call that the equinox. In fact, we call this the autumnal equinox. And then over here we've got 3/21, which is the vernal. And the word vernal means spring. Okay? So now if we shade in the nighttime views for each, so I'm going to color this one completely in dark because from our view, we're seeing the backside of the Earth. The sun's further away, so this is pretty much dark. And then this guy, the dark side's behind us, behind it, so we can't see it. So if I have star X if you're on December 21st, you could see star X, but on 6/21 you can't because it's daytime from your perspective. You won't be able to see it. But star Y you would be able to see, and vice versa. 12/21 could not see it. All right. So, question? The equinox is 12 hours a day and 12 hours a night. Yeah. That's everywhere on the planet. Whether you're at the North Pole or at the equator, it's going to be 12 hours a day and 12 hours a night. Equinox is equal night, yeah. All right, so our answer for this one would be the Earth revolves around the sun. 14, which letter represents the process of transpiration? Transpiration is a combination of two things, evaporation and evaporation from plants. Sometimes people call it tree evaporation, right? Because it's evaporation through trees. So which letter represents it? D. So that's transpiration. Let's label all these. Coming off the water directly would be? The cloud formation would be? Condensation. A, precipitation. Let's take it one further. The rainwater hits the ground. Has two choices. Where does it go? It can run off the surface. We call that runoff. Or it can go into the ground. And we call that, starts with an I, infiltration. The word infiltrate, to go in somewhere, or to filter. Water filters through it. Cool. Next up, 15. Cross-section below represents a lake effect snowstorm that resulted from air moving across Lake Ontario and over Oswego, New York. These lake effect snowstorms commonly occur in the region around Oswego during the winter. Yes? Go for it. Because Lake Ontario does what? Water holds on to heat. So the water is going to warm the air, which causes it to rise, which causes it to expand, cool to the dew point, and form clouds and snow. The answer is 4. What is 4 literally explaining? Excellent. Adiabatic cooling. Adiabatic cooling, where the air that's warm goes up, expands, cools, hits the dew point, causes precipitation, in this case, snow. Yes? Cumulonimbus and stratus. Cumulonimbus clouds are thunderstorm clouds. These are cumulus clouds. Cumulus is big, fluffy. Cumulonimbus are the ones that go up and they form that anvil shape that we looked at. Those are the ones that make tornadoes. That's cumulonimbus. And then the last one are the wispy guys that kind of look like that. Those are technically ice clouds, and those are usually up at like 40,000 feet or more. It's frozen water vapor, and they're like little wisps. Those we find on clear days, where these guys we would find on rainy days. In particular, cumulonimbus is on thunderstorms. Question 16. Assuming that no overturning of rock layers has occurred, which geologic outcrop containing New York State index fossils represents the correct sequence of time? This is time consuming, so I'm just going to jump to the right answer. The right answer is 3, but let's figure out how we got that. We're going to go to reference tables pages 8 and 9. So let's look at that funny looking guy right there. This is the only dinosaur fossil in New York. Her name is Coleophysis, and Coleophysis being letter L, we can find letter L over here. Now, if we zoom out and we move across to page 8, we can see that Coleophysis was around about 200 million years ago. So I'm going to write 200 right on her chest. And we got this funny looking guy. What is that? That is letter N. That's Styloneurus. Well, letter N came around during the Devonian at around 400 million years. So I'm going to write 400 on it. And then lastly, this guy is letter M, and letter M we could find is down here. Letter M was during the Silurian during 440 million years ago, and you could see that that is the furthest down. Now, remember, we have the law of superposition. The law of superposition states that the farther down, the older the rock. So this makes sense. Now, if I found a human bone down here and a dinosaur fossil up here, that would tell me that there was rock overturning. Now, in this case, I think it says there was no overturning of rock. So that means that these are all exactly as they were laid down. So that would make sense. Question? Overturning is when the order is upside down. If we literally flipped that on top, kept that the same, and put that on the bottom, then yeah. It's rather uncommon then. 17. Equal areas of which type of surface absorb the most insulation? Vocabulary word, insulation, incoming, solar, radiation, insolation. So incoming solar radiation or sunlight is going to get absorbed by what? Dark colors or light colors? Dark objects absorb stuff. Wear a black shirt on a summer day and a sunny day and you'll know. But is it smooth or rough that absorbs? Rough. Mirrors are smooth and mirrors reflect. So light colored reflects, smooth reflects, dark colored absorbs, rough absorbs. Which material requires the least amount of heat energy to raise its temperature 1 Celsius degree? This is what we call specific heat. Specific heat is the ability to hold on to heat. Liquid water holds on to a lot of heat. So if you got an empty 2-liter soda bottle, you filled it up with boiling hot water, put the cap on and threw it in your bed, it would keep you warm all night because it holds on to so much energy. But if you got a piece of metal, and you would think metal holds on to heat, right? Because I know I got burned from touching hot metal before. Hot metal doesn't hold on to heat very long. Let's take a look. If you go to reference table page 1, you could see that common materials such as liquid water, could have really, really high specific heat, or like lead, very low. So lead doesn't hold on to heat. Copper doesn't hold on to heat very well. It gives it off really well. But I think the lowest one on the chart is granite, according to this. 19. One characteristic of a good index fossil. Well, what makes a good index fossil? It's a couple things. One thing would be it's found over a wide area. And the other thing was it's only for a short period of time. So, no, we're not going to find fossils in igneous rock. That just doesn't happen. Probably not metamorphic either. Lived over a wide area. That's it. Boom. Humans make an excellent index fossil. Because if you find a human skull in the ground, you know it was from the last 1,000,000 years or so. Because humans have not been around, especially not modern humans. If you look at dogs have only been around for like 30,000 years. So if you find a dog fossil, it's recent. Another good example of a fossil that could be an index fossil is trilobites. Now, trilobites aren't great because they were around for a long period of time. But if you look at reference table page 8, you can see we have all these different kinds of, these different kinds of trilobites. You've got nautilus. But these guys were only around for short periods of time. So, and they were all over the planet. So these are good index fossils. Yes? Why wouldn't it be 4? Question 4. Live both on land and water during part of their lives. Because whether or not you are an aquatic or marine organism doesn't really matter. It's really wide area, short time. 20. During which geologic epoch was nearly all of Earth's land masses inferred, or guessed, assumed, to have been located in the southern hemisphere? Earth Science Reference Table, page 9. If you go to page 9 and you look at these pictures of Earth, this is Earth almost what it looks like today. But as we go further back, you can see that the land masses seem to have shifted more north. They were more south in the past. So I would say during the tectonic orogeny, which happened during the Ordovician at around 460 million years ago. So our answer would be 4. The Allegheny orogeny occurred as a result of the blank. The word orogeny means mountain building event. Yeah, so this is when mountains were formed, like the Adirondack Mountains that are here in upstate New York. Those mountains, they were formed about 1 billion years ago, I believe. Some of them, or part of it at least. And that was that one event. The Rocky Mountains are younger, so they're newer, right? So let's take a look. If we go to page 9 and we find the Allegheny orogeny, it was caused by the collision of North America and Africa. The answer is 3. If you know where to look on this reference table, you can get all the answers. 22. Question? You're going to get the exact reference table you're looking at right now. It's just not your own. 22. Which concept states that most sediments are deposited in layers that are flat and parallel to the Earth's surface? We already talked about the principle of superposition. Oldest is on the bottom. Cross-cutting relationship. This is when we have an intrusion cut through. That is not what's happening here. Dynamic equilibrium has nothing to do with those layers. Original horizontality. Just like when you walk into a room that hasn't been cleaned in a long time, we find a nice thin layer of dust on everything. Notice it's not like dust only in that area. It's going to be dust everywhere and thin and horizontal. 23. Which layer of the Earth's interior is inferred to be made mostly of iron and nickel and has an interior temperature greater than the melting point? If your temperature is greater than the melting point, that means you're melted. Which is the liquid layer? Got to memorize this. The outer core is liquid. And hopefully before the bell rings, we can go over this last one. It says here, the temperature of the outer core is higher than the melting point. Therefore, the outer core is liquid. Hold on to these. We went up to 23. I was hoping to go a little bit further, but we will get through this.